What is the amyloid cascade hypothesis for Alzheimer's disease? Imagine a tiny protein fragment called amyloid beta that can build up in the brain over time. The amyloid cascade hypothesis suggests that this buildup is the starting point of Alzheimer's disease. According to this idea, when amyloid beta accumulates and forms sticky plaques, these plaques disrupt normal brain function. This triggers a chain reaction leading to the formation of tangled fibers called neurofibrillary tangles, which are made of tau protein. These changes damage and kill nerve cells, causing memory problems and cognitive decline that we see in dementia. This hypothesis was first introduced in 1990 by scientists named Hardy and Higgins. They proposed that the main cause of Alzheimer's is the buildup of amyloid beta in the brain. They believed that other features of the disease, like tangles and neuron loss, happen as a result of this initial amyloid buildup. The idea is supported by genetic studies showing that mutations in genes related to amyloid production can cause early-onset Alzheimer's. For example, mutations in the gene 4 amyloid precursor protein or in genes 4 enzymes that cut this protein can lead to increased amyloid beta and early disease development. People with Down syndrome often develop Alzheimer's symptoms early because they have an extra copy of chromosome 21, which contains the gene 4 amyloid precursor protein, leading to more amyloid production. Amyloid beta is produced when a larger protein called amyloid precursor protein is cut by two enzymes, called beta-secretase and gamma-secretase. Depending on how these enzymes cut the protein, different forms of amyloid beta are created. The most common forms are a beta-40 and a beta-42. The A-beta-42 form is more likely to stick together and from the plaques that are characteristic of Alzheimer's disease. While the amyloid cascade hypothesis has been influential and guides much research, it is not without controversy. Some scientists argue that amyloid plaques might be a side effect rather than the cause of the disease. Others point out that treatments aimed at removing amyloid in the brain have not always been successful in slowing or stopping the disease. This suggests that other factors, such as tau tangles, inflammation, or vascular issues, also play important roles. Despite these debates, the hypothesis remains central to understanding Alzheimer's disease. It connects the molecular changes in the brain with the clinical symptoms of memory loss and thinking difficulties. Many current therapies are designed to reduce amyloid buildup, aiming to slow the progression of dementia. Still, ongoing research continues to explore whether targeting amyloid alone is enough or if a combination of approaches will be necessary for effective treatment. In summary, the amyloid cascade hypothesis proposes that the accumulation of amyloid beta in the brain is the initial event that leads to the complex chain of changes causing Alzheimer's disease. It is supported by genetic and pathological evidence but remains an active area of research. For anyone concerned about memory loss or dementia, it is always best to consult healthcare professionals who can provide personalized advice based on the latest scientific understanding.